Okay, on page 146, we're just going to review the rules and laws of exponents. Up top, on the top of the page, there are 6 key rules that you need to make sure that you know. And they're right there in this green box that I've made. So if you have 2 things and their bases are the same and they have 2 powers, then you really can just add the powers. The key being the bases here, the a's are the same. If you have 2 bases that are the same that are raised to different powers, you subtract the powers. If you have 2 things inside parentheses raised to an exponent, both things on the inside of the parentheses get the exponent. Same idea if you're dividing, they both get the exponent top and bottom. And all this says is that the denominator can't be 0. An exponent raised to an exponent, you multiply the exponents, and anything to the 0th power always equals 1. So now we're going to do some examples. So number 1 says to simplify. Well, I'm going to start by doing parentheses, nothing inside I can do. Now everything it needs to be squared. So 3 squared is 9. X squared squared, you multiply these so you get x to the 4th and then you get y squared. So there's the answer to number 1. Number 2, I'm going to start on the inside. A negative 2 squared means negative 2 times negative 2, which gives me positive 4. Positive 4 raised to the 3rd power means 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. Number 3, I'm going to take my numbers, I'm going to divide them first. So 12 divided by negative 4 is going to get me a negative 3. And the a's, when you have a power divided by a power, that's like rule number 2 up here. So what you're going to do is 7 minus 3. 7 minus 3 is 4, so a to the 4th. Number 4, the xy squared is being distributed into both of these, so it's like 3x squared xy squared plus 2y squared xy squared. Then if you simplify, I have 3. X squared times another x is going to make x cubed y squared plus 2x, and I'm writing the x first because I wrote the x first here just out of mathematical habit. Y squared and y squared, you add these powers so you get y to the 4th. Number 5 should be your favorite problem because anything raised to the 0th power is simply 1. Number 6, because I have the same base and these are multiplied, this is like rule number 1. So really what I'm going to do is 4 to the y plus 2 plus 6. This is like saying 4 to the y plus 8th power. Number 7 gets a little bit trickier, so we're going to go piece by piece. I have to square the top and the bottom. So these 2 powers get multiplied, so you're going to have a to the 4th over b squared. And then you have a squared b squared. And this is all raised to the 3rd. So really what you have is a to the 4th over b squared. And then you have a to the 6th, b to the 6th because you multiply. This is like a to the 6th, b to the 6th over 1. So on top we have a to the 4th, a to the 6th, which is the same thing as saying a to the 10th. And then on top I have b to the 4th, and on bottom I have b squared. And that means you're going to subtract, and so you really have b to the 4th. And I really just want to do number 7 again, but I want to draw it out for you. So on top, you're going to have a to the... Oh, I made a boo-boo. I didn't even take this square and give it to this one, so this should have been a to the 8th. And this should have been a to the 8th, which would have made this a to the 14th. Okay, so up here you have a to the 8th, which is like a, 1, 2, 3, 4, 5, 6, 7, 8 A's. On bottom here you're going to have 2 B's, and then on top here you're going to have a squared cubed, which is 6 more. 1, 2. And then up here you're going to have 6 B's. And so visually to do this problem, on top you have all these A's, which means there's 14 of them, which is where this 14 comes from. One of these B's cancels out with one of those B's. One of these B's cancels out with one of the B's, so you're left with 4 B's on top, which is where that comes from. Okay, so now we're going to kind of use a little mathematical logic and we're going to solve. So I have 3 to the x, 3 squared. Since these bases are the same, I can rewrite this as 3x plus 2 equals 3 to the 8th. So I have an equation and they equal each other and both bases are the same, and since the bases are the same, then the x plus 2 has to equal 8, or the two powers have to equal each other, which means x has to equal 6. And then finally on number 9, a little bit of simplifying. On top you're going to have 3 to the 2x over 3 squared equals 3 to the 8th. You're going to subtract these, so you get 3 to the 2x minus 2 has to equal 3 to the 8th. Bases are the same again, so 2x minus 2 has to equal 8. I'm going to add the 2 over, which is going to get me 10, and divide by 2, which is going to get me x equals 5. And there's your final answer. Go back to Edmodo, and there will be another video there for you to do pages 149 through 150.